Then you might be asked, explain various types of architectural patterns, architectural design patterns. You know that? What are the various architectural design patterns? Any design pattern you have heard or you know that? A few of them we already discussed. Monolithic architecture. Then layered architecture.
I think microservices.
Yes, service oriented. Architecture. This is known as SOA. Microservices architecture. Right, layered, it can be n tier, 2 tier, 3 tier, right, n tier. These are the major ones, right? Monolithic, layered, service oriented, microservices, event driven. These are the major ones. There can be others, but you need not to know every pattern. Microkernel, space based, pipe filter, broker architecture, peer to peer, right? But major one I told you, SOA, microservices, event driven, n-tier or layered, monolithic. These are some of the design patterns, right? So architectural patterns, monolithic, you all know that, which is the traditional one, the oldest one. There's only single box, right? Where everything, all the front end, back end, middleware are enclosed in a single container or a box. If something goes wrong to any one of the components, the whole system is down. But in layered, you have a separate layer for front end, back end, and middleware, right? So there is a flexibility, or they are loosely coupled. You can independently develop these components. Then service oriented architecture is also a kind of layered architecture, but in that case all the front end and middleware applications are different, but databases are common, right? So this is also one of the patterns which are being used based upon the concept of, you might have heard, PEPL, BPM, right? Business process management, BPM, or they fall under the category of SOA architecture. Before microservices, SOA was very popular. Then we have microservices, where each application component is divided into a smaller sub component. That is microservices architecture. This is one of the latest architectures, but at the same time it is complex and difficult to manage because there are many communications between each components. So though it is reliable, and this is more efficient one, but at the same time it is complex. Event driven architecture, like online shopping, e-commerce applications, they usually use the event driven. Whenever there is an event, let's say click on purchase button, add to cart, making the payment, these are the different events, right? As and when you click on the particular option on your website, a corresponding action will be taken. That is event driven, right? So we also use the message broker as part of event driven, and or there can be you can use it independently, broker architecture. Then peer to peer. So there are some others, but they are not very popular. Layered architecture, I just explained you that. Each layer, front end, back end, middleware, they are having a separate layers, right? So you can independently work on that. Then this is the client server architecture. As the name suggests, there is one server and there is multiple clients, right? So this is also kind of client server architecture. Okay, so drawback is that there is a dependency on a single server, right? And there are multiple clients. That's a problem, that single point of failure means there is a dependency on the single server. If that is down, the whole application is down. So single point of failure is there. Event driven, I just explained you that in case of online applications, shopping applications, e-commerce applications, they use the event driven, right? Then microkernel, you can skip it. Microservices architecture, I told you that each application is divided into a sub modules or components known as microservices, right? And space based, you can leave it. Pipe filter is a kind of just like a queue, right? There are pipe and filter, means you send some data from one end and there are multiple intermediate filters, right? So based upon that, your information is passed from one level to another level, right? So filters are used to process the data, right, from one end to another end, from source to sink, right? It is best suited for web-based applications that handle data in a stream and can generate simple to complicated structures, right? So in web applications you use the pipe and filter, right? But not very common as we discussed the other patterns, right? The drawback is that inefficient and inconvenient, because as the filter means not every component will require the full set of data. So full set of data throughout the entire pipeline, filter it. As and when the information is required, you pass on that information after filtering it. So the full data is not available, right? But the advantage is that you send only that information which is required by the user, right? So that way you filter the information and send to the from source to sink.